All right, so welcome to 223. Good. Glad you're doing well. All right, so I would like to continue talking about um, threads and networking today, and look at an example of putting together a full server-side connection in Java. And this is related to, what you're trying to do in PA5, so hopefully this will be helpful if you're having trouble sort of seeing the kind of overall big picture of how these things go together. So I want to do that today, which will take us up to talking about dealing with multiple processes and some of the things that can go wrong in that situation. And we'll dig into those further tomorrow, right, which is Wednesday. And then Thursday I'm going to do an open lab. So, PA5 is due on Friday, so Thursday I won't lecture. I'll be available during class time. And hopefully if you're having issues with your code, right, you're going to catch me in office hours before then. But, worst case, last chance, Thursday during class, open lab time. And then Friday, we'll, wrap up talking about threads and stuff. And then we've got a week left. And in that week, I want to talk about, some other aspects of networking, the URL class, things like that. I'll probably take a day and talk about Android development, because Android, is Java, or maybe Kotlin, but, it's running on a JVM. And the general experience of designing a graphical interface for an Android app is very similar to what we're doing with Swing and Window Builder, right? Same ideas of responding to events, and painting from a particular method, and so on and so forth. So it's a good opportunity to sort of take a step sideways and look at these concepts applied in a different domain. And it's fun to write Android apps because you can buy an Android phone for 20 or 30 bucks and write code for it. And they've got these bundles of goodies inside, acceleration sensors and GPS and all that kind of stuff. Plus messaging capability. So it's a good way to take everything we've been doing and learning and apply it to a pretty modern platform. So we'll do that one day next week. We'll spend a couple of days doing some wrap up and review for the final and talking about logistics for the final. And then whatever time is left, we'll fill in with any of the number of things we can talk about in an advanced data structures course that we haven't gotten to yet. So we're in good shape as far as we'll get through everything that we need to get through, and we may have a little wiggle room to get into some other fun topics. But the end is coming soon. SLP is definitely not the same as a final exam. So the final exam will be during finals week, which is not technically being called a finals week this quarter, but it'll be that Monday, and it will... I'm only allowed to give a 1 hour final apparently, so if I want it to be longer I may break it into 2 days, but we'll see. But there'll be some kind of final that's on par with what we did for the midterm. Alright, so any questions before we get started on all this? Or any other questions? So we're going to do this from Eclipse, just because. And so let's make a full server class. And here's what I want to do. I want to expand on the server that we've been developing as follows. So I'm going to still use telnet as the client, but we're going to make a server. And I would like to be able to have two-way communication between the person who's running the server and the person who's running the client. So the typical setup's going to be, do some initialization, create a server socket, accept a connection, all of that stuff. And then I want to read a message from the client. Okay, and on the client side, it's going to do some initialization. It's going to read from standard in, from the keyboard, and it's going to send whatever the person types on their keyboard. It's going to send that to the server through the socket. So that's going to go over to the server. Maybe I'll put this up here. And what the server reads from the client is going to print to standard out. And the server that we wrote before basically just did these two things in a loop. It read a message from the client and it printed it out. Read a message, printed it out. I want two-way communication, so after I print that out, I'm going to read from standard in, and then I'm going to send to the client. And the client is going to read from the server, and then it's going to print to standard out. And then we're just going to loop. So the person on the client side types something, hits enter, it gets sent to the server reads that, prints it out. And then the person on the server side types something, hits enter, that gets sent to the client reads it, prints it out, and then you go back to the top and you do this again. And so you can take turns sending messages to each other. So let's put that together. And we're not going to do any threads yet. We're just going to put this together very carefully. So I'm going to make a server socket. So that'll allow us to get connections from the client. And then I'm going to want to read from the client. So I'm going to make a socket called from client. I'm going to make a scanner called from client. And I want to send to the client. I'm going to make a print writer called to client. Okay, and both of those are going to be created by constructing off of a socket. So I'm going to make a socket. I'm just going to call it client, and this is a socket that is connected to the client socket. Okay, so I'm going to have a scanner, which I'm going to call from client. I'm going to say read from here to get what the client sends. And I'm going to have a print writer which I'm going to call to client. And right to here to send stuff to the client. Okay, I also need to print the standard out. Well, that's just going to be system.out.println. I don't have to do any work for that. I also want to read from standard in, so I'm going to use a scanner for doing that. And I'm going to call this, I don't know, I'll just call it standard in. That seems like a good name for standard in. So that's going to be a scanner, standard in. And I can just construct that right now. So use this to read from the keyboard. Alright, so those are our basic variables. Let's go ahead and set up our imports. This is one nice thing about IntelliJ. If you do this in IntelliJ, it'll say, you know, you've got 80 billion similar errors that can all be fixed the same way. Would you like to fix them all right now? And you can say yes, and it'll go ahead and do those imports for every class that you haven't defined an import for. That's not enough to sell me on IntelliJ, but it's a nice option. Alright, so we've got our basic objects that we're going to use for two-way communication. And I'm going to be sloppy and put everything in a try-catch block, because I'm not being graded on this. And I have a very descriptive error message which says error. So what do we want to do here? We want an infinite loop. Well, so first we want to establish the connection. Okay, so we create a server socket to listen for connection requests. So SS is our server socket. And we have to give it a port number, and I don't know what today's port number is. Today's port number is, what is it? It's June 2nd. Okay, so we'll do 602. So we're going to accept a connection on that. So when we accept a connection, we get a socket back. Our socket is called client. So client equals server socket dot accept. Okay, and this call will block until we get a connection request. So let's put a print message in here. So we'll print a message when we're ready to go into accept. When we come back from accept, we'll print a message saying we got a connection, and we'll print out what this socket is that we got from the accept call. Alright, so so let's loop here. Read from the client print to standard out. So yep, there's one more thing we gotta do. We gotta make our print writer and our scanner. Alright, so our scanner is from client. So create a new scanner using the client sockets get input stream method. And then toClient is a print writer. And construct that using the client's get output stream method. And then we'll loop. Alright, so while from client has a next line, okay, so while there's another line coming in from the client socket, let's just read that next line and print it out. So we'll see what the client sent to us. And now let's read from our standard in and send that to the client. So let's do string buffer equals, so what's our standard in scanner called? It's called standard in dot next line. And then we'll do toClient.println, and we'll send the buffer. And we'll remember to flush the pipe so that we force all the stuff to go out right away. And that's the end of our while loop. And let's just print a message when we come out of our loop. Like that. I'm going to put a comment here. This is dangerous. Right? Generally when we have a scanner, we don't want to call next line unless we first called has next line and gotten a true back. If I hit Control D to signal end of input, I'll throw an exception when I try to do next line. I should do has next line first, which would then return false and stop me from calling next line. But I'm being lazy. I'm just trying to talk about the socketed aspect and the threaded aspect of this, so I'm not making this totally solid. Just like I'm not being nuanced in my try-catch blocks, I'm putting all of this inside one big try block. Don't do this, okay? You know, unless you're in a rush like I am. So, so this is dangerous. This will throw an exception if I were to type Control D, for example. But I won't do that. Alright, so here's our basic loop, right? If there's another line coming from the client, read that in and print it. And then read a line from our keyboard, send that to the client, flush the socket connection, and just do that in a loop forever. Until there's no line available from the client, meaning that the connection has been closed, print out a message and return. Alright, so this is our server-side connection. And I can go ahead and run that. I can't connect to port 602 because ports below 1024 are privileged. So I'll do June 2020. Alright, so we're ready to accept a connection. Let me shrink this window. And let me open a telnet window. And let's telnet to our local host 62020. And we've got a connection. Okay, and over here it said got a connection. Local address was, you know, my machine 127.0.0.1. The local port, right, the port that we were connected to is 62020. The port that we're connected from is 42160. That's the port number over here that was created by the telnet client to say, hey, I want to talk to, you know, this port on localhost, because you always need a pair of sockets. Okay, so I can type something like hello and hit enter, and I see that message pop up over here. And I can say hello back, and it pops up on my client side. And so I've got two-way communication going between a client, which I'm just using telnet for, and a server, which we've written in Java. And if the client exits, and the way you exit telnet is by doing a control right bracket and then a Q, then I get a message saying connection was closed and my process exited. My little run button stopped being read. Okay, so we have this two-way communication going. That's good. What's missing, and this is probably good enough for PA5, okay? But in a more general context, there's a problem with this, which is suppose that, you know, the client says, hello, I have a lot to say. Here I go. They send 3 messages. I've only seen their first message. And if I say, nice to meet you, right, they get that message from me, and immediately I see the second message that they sent. And I can say, you type fast, and there's another message that they sent. And so I can say, wow, and that comes out on the client side, and I say, this is cool. I like typing to myself, haha. And now I'm typing a bunch of things on the server side, and it's not showing up on the client side. Until I send something, and then each time I send something, I'll see another message that was sent from the server. Alright, so what's going on here? It's pretty obvious, right? The server side is set up to move in sync with the client side. Read a message, send a message. Read a message, send a message. And if I type 5 messages that I want to send, I don't get to send the first one until I read a message from the client. And then I get to send 1 message. And then when I come back up here again, right, I'm waiting to read another message from the client. Okay, so there's terminology for this. The terminology is we're using a blocking read. In particular, up here in the top of our while loop, we're saying, well, from client has next line, read the next line from the client. Okay? This is a blocking call. When we go into has next line, we don't come out of that until there is a next line available. Right, and I think this is how it's actually described in here. Right, a scanning operation may block waiting for input. Okay, that's what it's referring to. This idea that when we're saying, you know, is there another line available from the client, we won't come out of that until either a new line is available or something happens and the connection shuts down and it can say, no, there's not a next line available. Okay, it's a blocking read. And so it doesn't matter if we type a whole bunch of things that we want to send. If we're sitting here in this read from client call, we don't come out of that until something's available. And when we come out of that, we read, you know, a line from standard in and we send it to the client. And then we come back up here and we're blocked until we get another line from the client. Okay, and this is a classic problem with doing this two-way communication. You have to move, you know, send a message, send a message, send a message, send a message. You have to take turns. Okay, and that's not usually what we want. So one way around this is to use a non-blocking read. And different languages have different ways of enabling this. And the idea of a non-blocking read would be, instead of saying, go into this method and come back when there's another line available, we could say, tell me if there's another line available or not, but come back right away and tell me. If there's not a line available, just tell me that. Don't wait for one to show up. So it would be a call that we would go into and it would come back pretty much right away and say, is there anything available? So that's a non-blocking read. And if we use a non-blocking read, then we can say, you know, check for input from the client, and if it's available, read that input and print it. If it's not, just come down right here, check for input from the user. If it's available, read it and send it. If not, just skip over that and go back up here. And that'll work in terms of being able to do the two threads independently of each other, being able to send and receive whenever you like. The problem with using a non-blocking read like that is now you're very CPU intensive. Okay, now you're going to be constantly going through this loop saying, you got anything from the client? No. Got anything from standard in? No. Got anything from the client? You're just going to keep doing that in this while loop. That's very CPU intensive. And, you know, barring multiple cores, if you've got a loop that's always ready to do something that the CPU has to deal with, it slows down your system, right, significantly if it's a single core. So that's inefficient. So blocking reads are nice because when you're waiting for this input to happen, you're not using CPU time. Okay, so I've got my server running right now. I'm sitting inside this has next line. If I do a PS, somewhere in here, there's my main program right under my full server. This is the command that is running, waiting for that next line from the client. This S over here tells me it's in a search state, it's in a sleep state. Okay, the process is not consuming CPU time. In fact, it started at 14:22, so about 7 minutes ago, and it's consumed 0 seconds of CPU time. Okay, as opposed to, you know, my ecosystem simulator, which has consumed 4 days and 22 hours of CPU time, right? Or my Eclipse window, which consumed 2 minutes and 11 seconds of CPU time, right? This is very CPU friendly. So we like blocking reads, but we want to be able to move things independently of each other. This is where we're going to use threads. Okay, so to fix this with threads is very straightforward. All we got to do is break it into two processes. One which reads from the client and sends the standard out, and then a separate thread which reads from the keyboard and sends to the client. And if we make this a different thread, it will run at the same time as this, and if we're blocked in here, it doesn't stop us from typing, hitting enter, and having what we typed go immediately to the client. So using threads is the way we're going to deal with this blocking issue. Okay, and like I say, this is kind of beyond PA5, because PA5, we know that, you know, after you send something, I'm going to send something. After you send something, I'm going to send something. But if you do threads for PA5 anyway, right, it's going to make your code a whole lot easier to develop and debug and work with. So let's break this server class into our main process and a thread. So I'm going to stop my server over here, and you notice that the client side detected that connection closed by foreign host, and it just exited gracefully. Alright, so let's make a new class. And what should we call this? So this is going to be our main thread. Let's make, I don't know what to call a thread today. I'm running out of imagination. Let's call it Doug. Like Bob and Doug. Okay, so I'm going to make a new class called Doug. And I'm going to say Doug extends a thread. So this is the class that reads from the keyboard, which is standard in, and sends to the client using toClient. Alright, so how do we do this? We're going to keep our main thread here, which reads from the client and then prints it out. And we're going to end our thread right there. And I'm going to take these 4 lines out. I'm going to put them in here. Alright, so our server class is simpler now. Same setup as before, but then our main loop basically says, while there's a line coming in from the client, read that next line, print it out. And we'll just do that in an infinite loop until the connection closes. We'll print out a message and we'll return. Okay, so before we do that, we have to make an instance of this thread class, and we have to start it in a new thread. So, Doug, new thread equals new Doug. And we'll go ahead and call a start method, and we know that will create a new thread, and it will run the run method of that object in the new thread. Alright, so now we got to set up our thread class. So we're going to have a start method, run method that gets run when we call start. So that's going to be public void run. Which will read standard in and send it to the client. So here I'm going to be safe. I'm going to do while standard in has next line. I'll read the next line from standard in. I'll print it out to the client. I'll flush the socket, and I'll go back to the top of my loop. And when I get to the end here, I'll say goodbye. Alright, so that's our run method. The one thing that's missing is we haven't defined these things to client and standard in. Okay, I've already set these up in my code over here, so I'm just going to pass those to my new thread class when I construct. Okay, I could construct them inside my new thread, but we'll just do something different here. So what do we need in here? We need standard in. So that's a scanner, and then we need toClient, which is a print writer. And so let's make a constructor over here. So public Doug, and so it takes a scanner called SC, and it takes a print writer PW, and first argument is standard in, and the second argument is toClient. And let's just declare these things to be class variables. And we'll do our imports as usual. This is toClient. All right. So what have we done here? What's the link up here? We're going to start our main method. Okay. We're going to create a server socket. We're going to accept a connection, which gives us a client socket. We're going to construct a scanner and a print writer for talking to that. And then we're going to make this new thread called newthread, and we're going to pass it, the scanner that we created on standard in up here, and we're going to pass it the toClient socket that we created right here, and we're going to say go ahead and start yourself, start your run method in a new thread. And so in that new thread, we're going to go into this loop which says read from standard in, push whatever you read out to the client socket, flush it, go back up, and do that forever. Alright, so if we run this, let's go ahead and open a telnet connection, and I can say hello, this is fun, ha ha ha, and everything that I'm typing here is coming out over here, even though part of this program is waiting for me to type something and send it. So I can type 2, yes I can. I can talk whenever I want. Well, if I'm halfway through typing something here and the client decides to send a message, it comes out right away even though I'm in the middle of typing in a line of input. So I can finish whenever I want, and that message goes in over there. And I can send the interrupting cow, and it pops out right there. Alright, so we really have two independent processes running now. One which is handling this reading from the client and sending the standard out, another which is reading from standard in and sending to the client. And they're totally independent of each other, right? Except they're both using the same socket to communicate with the client, but their actions are unlinked, right? This is just sitting in this loop. Anytime we hit enter, it'll send it to the client. This is sitting inside this loop, and anytime something comes from the client, it'll print it out. Okay, so that's a good setup. That's kind of a totally general server-side setup. And if we hit Control D over here, it says goodbye. And it comes out over here, and our thread has exited. Okay, well, that is completely independent of the fact that our main method was sitting inside this loop reading from the client and sending to standard out. Okay, so even though we hit a Control D, which caused our second thread to exit, right, it said goodbye and then it returned, our main program is still running. And I can still type things over here and send them to the server. Right? But there's nothing over on this side reading from standard in anymore. And so if I close down the client side, right, then the server side loop over here, which is reading from the client, gets a false when it says has next line, prints out connection was closed, and returns. Alright, so there's two threads handling two sides of the communication. Let me mention something that I mentioned in the earlier section too. This constructor that I made, right? I wanted to call my constructor with a pair of arguments. The first argument was going to be, the standard in scanner. The scanner lets me read from the keyboard. And the second one was going to be the print writer that lets me write to the client. Okay. In my constructor, I called that first argument SC for scanner and the second one PW for print writer, and I said standard in equals SC, to client equals PW. That's not horrible, okay? But, a better approach would have been to say something like, this is my standard in argument, and this is my to client argument. And so I'll set standard in to my standard in argument, and I'll set to client to my to client argument. All right, instead of having these like weird names like PW and SC here, right? But you know, if I'm thinking of this in my head and I've got, you know, a naming scheme in mind and so on and so forth, this first argument really should be stdin, right? And this argument really should be toClient. And what I'd really like to say is something like this. Right? I really want this argument to be standard in. That's what stdin means to me. It's the scanner I use to read from standard in. This is toClient. It's the print writer that I use to send to the client socket. But these statements are silly, right? Saying standard in equals standard in doesn't do anything. And what I really mean is I want this standard in up here to be set equal to this standard in that was passed to this constructor. And I want this toClient to be set equal to the toClient that was passed to the constructor. And there's a way to do that. And that is put the keyword this in front of the thing that refers to the class variable. So remember, this is the ego. It's the sense of self. So inside an object, right, newthread in this case is an object of type Doug. Inside newthread, this refers to newthread. So this is saying newthread.standardin, that's this variable right here. And this statement therefore says set this variable equal to this argument. And the second statement says set this variable equal to that argument. Okay, so this is a really powerful keyword, and this is a place where you'll see it used a lot in code that you look at. Okay, it's a way to force standard in not to be this local variable, but to be the class variable instead. Because there's always this notion of scoping, right? And things that are defined multiple places, the thing that this refers to is the one that's defined most closely. So there's a standard in inside this method. It's an argument. That's what standard in refers to. So this .standard in gets you outside of that. And I usually teach this keyword early in the course, but it leads to needless things like this. Right? You can do that, but there's no need for that. This is explicitly saying the class variable called toClient, which is up here. Well, at this point, toClient, it has not been defined in the run method. It's not defined here. It's not defined anywhere except in the class variable. So just plain old toClient means the class variable named toClient. But inevitably, students start putting the keyword this everywhere, and that's just kind of redundant, and it's needless and potentially confusing. So use this if you have a case where, you know, without it, you'd be referring to the wrong variable. For example, stdin would refer to this, and we really wanted it to refer to that. So we say this.standardin. That's a bit of a sidebar. But anyway, it's a good place to mention it. All right, so where are we? We have 2 threads running. Okay, on the server side. Now, if we were writing the client side also, we would do the same thing over here. We'd have a thread here. We'd have a thread here. We would have 4 threads running. You notice we use the main program to handle this loop, and then our new thread, Doug, to handle this one. A different way to do this might have been to have our main program create 2 threads, right? And maybe this would be, you know, the Bob thread, and this would be the Doug thread. And our main program would do nothing but wait for a connection request, accept the connection request, create and start a pair of threads. And then the main program could go back and wait for more connection requests. And when a request came in, it could create a pair of threads. And now you've got a full-blown server, right? Or something that's called a daemon, which is close to a daemon, but spelled differently. But it's this thing that hangs out in the background and basically serves up, you know, responses to requests. And so there's a mail daemon, there's an FTP daemon, there's a login daemon, there's an SSH daemon, there's a web daemon, there's a print daemon, all of these things that you might want to communicate with through sockets, right? There's a process that basically, main responsibility is to accept connection requests and then set up, you know, 1 or more threads to deal with that request. And then the daemon just goes right back to waiting for more connection requests. Alright. That's a pretty clean example. We're going to make things ugly tomorrow. Because this thread can do its thing, and this thread can do its thing, and they're pretty much independent of each other. Right? This is reading from the client, this is sending to the client. Things get more interesting when you have two or more threads that are trying to interact with the same objects. Okay? Now this is reading from, this is sending to. It's the same socket, but those are sort of independent operations. But suppose you had two threads that were both sending messages to the client. And suppose one thread was sending the message, hello, and the other one was sending the message, cool. And these are both going to the same socket. Well, what happens if these things get mixed up together? Right? And that can happen. If you don't have some sort of synchronization between these two threads, and they're just like, well, I'm going to send these characters to the socket now, right? There's nothing to stop this from happening. So we'll start looking at some examples tomorrow of where we can get into trouble with this, and then we'll talk about ways to deal with this. So we're going to talk about the idea of atomic operations, and that'll take us to talk about mutexes and semaphores and good stuff like that. And we'll see how to deal with this in Java, but we'll put together some Java code that will break in glorious fashion because of this kind of uncontrolled multiple access to objects. And then we'll see how to fix it in Java, and it's very easy to fix in Java theoretically. We'll talk about dining philosophers, which is a thought experiment, classic problem for exploring these kinds of issues. And we'll explore that space, and that'll take us up to Thursday, Open Lab, and then Friday, talking more about networking. Alright, have a great rest of the day. I will see you next time. Thank you.